I thought I might make this video just for your amusement, but also to make a point, actually, that there is a limit. There are several limits that one discovers when doing these sorts of experiments, and it's I think it might be useful for you to know what some of those limits are. What kept happening for me, well, initially, I was trying like different numbers of threads to queue the messages, right? And at the end, I have this, I renamed this wait multiple, like wait for multiple objects. And I tried like 100 threads, and this thing, wait, was asserting on me. It would come back with a fail. And then I looked in the help. No, I got two of these going. How about that? Wait for multiple objects. Well, it turns out that there's a maximum number of objects that you can wait on at any given time, and that number is not very big. In fact, great. I named it something that's, I don't know what this. Try and clean up a bit here. Get rid of you. Get rid of, whoops, don't need that. I'm sure it's plenty messed up at this point in terms of all the renaming and changing things. So it can rebuild its intelligence. See? And maybe, just maybe, when I ask for the definition where this function is, it'll take me there. Maybe not. But anyway, that limit happens to be 64. Now what they suggest is what they suggest. They have two suggestions. Oh, it's closer. Didn't take me to the function. Current project. On the right. Okay, now max wait objects, as I said, is 64. Okay. You can't wait on any more than that at any given time. Now where's the function where the wait actually does occur? This is the base function. What they suggest is two things. One thing would look very, very complicated, and the other thing sounded easy enough. If you got more than 64, okay, yeah. Create a thread to wait on that many object handles, right? And then just wait on that thread, plus the other handles. In fact, I did that, and that was working great for up to maybe 500 or 600 threads, right? But when I got into the really big numbers, like 5,000, even as little as 3,000 threads, it still crashed. And I get this thing, wait failed. And then I noticed that the thread, the signals that I was waiting on, which are threads, had no handles. Their handles were empty, and I couldn't believe it because I wasn't getting any warnings or anything from anything else, and I figured it must have been a bug of mine, with these arrays or something. But no, it just turned out that the code was written in such a way that it just assumed, it can't fail. It's not like that anymore. Now it must succeed. The only way to get out of the start function is for it to succeed. Otherwise, it's going to hang forever. Now, where is that? Start. Start. Where are we in TS thread? Create. Here. First, first this was create running, okay, and this was coming back null. And I noticed in the help under this function, which is really just a macro for this function, it says if newly created thread exits too quickly, begin thread might not return a valid handle. See discussion, blah blah blah. So I figured, well, okay, no problem. I'll create it suspended and make sure I get a valid handle, and then just resume, right, and then it'll be fine. And I still got these null handles. I was getting these null handles, and it's not, unfortunately, it's not, to get the description of the error, it's not that get last error, it's this DOS error that they use, God knows why. But I do have a function that will turn those into strings. And the error said not enough space. So then I had, first I had do while this is null and error equals not enough space. But then that crapped out. I didn't even bother to look at the error. I just said it like this, okay? Just keep looping. And when you get a handle, you can then resume the thread and go, right? And I put a little sleep here. And now, the thing that I noticed, oh yeah, let me just go back to the, what do you do when there's more than 64? If there's more than 64, first I had this all carefully worked out to, take the total number of signals you want to wait on, divide by 64, and for each of those groups of 64 you create one thread, so that reduces the number of handles you need to wait on by a factor of 64 for that part, and then plus the remainder, right? And it turned out that if you add 3,000, this comes up to 47, I think, and the remainder is such that this total becomes 104, which is still greater than 64, but doesn't matter because you see I'm calling the same function again, which would come in here and do the same calculation and have one thread plus, whatever, some amount. But really, you can do it in one step by just including whatever is remaining in just one more thread. So see, I had it all set up so that it's always array of this amount. But now what I've done is I've padded the rest with zeros. I have this thing that creates a thread, see, and it takes specifically an array of this many objects, and so does this thread object right here, right? So now I gotta just be careful and see how many there really are to compute the count. So I gotta count through, and when I hit a 0, then break, and whatever. It's the same thing, but You just have to be a little bit more careful. Now that creates, as I said, that creates 47. You come in here and you're asking to create 47 threads, okay? But the thing is, the reason I thought it was my bug, because it was always happening, the crash or assert was going on, at this part of the code. Because there's no chance in hell to create 47 threads at any point. Watch, I'll show you. I've got it all set up now. My old dialog displays the current number of active threads and a ratio, births over deaths, essentially. And what you're going to see is that there's a limit. There's a maximum number of threads, at least for this program, that you can have going at any one time. Okay, here they are, counting up. Now the maximum it got up to before was 1936, but then it did manage to get up to 1940. They're allowed to grow, as much as you want, up until that limit, and then the only way to get a new one going is to wait for another one to die. And you can't really tell by the printout, because how do you know that something got missed, right? Especially when I had didn't have this feedback. Oh yeah, and did you notice that this thing cleared? The other thing I thought, and well, it's probably true, was that I might be running out of memory, like malloc might have been failing, because when I'd break in and look at the address of my newly created array of signals to wait on, it's within that familiar range, 0x7 something, right? You can never go beyond, no memory address can go beyond that 7 FFF boundary, right? Even less than that. So if the numbers are coming back anywhere near those 7s, you're gonna hit a, malloc's gonna start failing on you. Okay, I got the recorder running now, so that might have some effect on at least the rate at which this grows. It's not growing very quickly. It seems to be stuck at 500. Right? That means that a lot of them must be failing to start, and it's just in that loop, right? Well, while the one of these things is in its loop, like this is still, in terms of the program, the Q program, whatever it is, it's still in this loop, right? They haven't been started yet. It used to be that it would zip through this and then I'd be sitting here waiting, but it's nowhere near there yet. We've only seen 740 births, and I've got it set to 3,000. So we're not even a third of the way through creating the threads. But the dequeuer is already going, obviously. One of the things I had wrong, not wrong necessarily, but I wasn't getting any feedback, because previously I had the dequeue start at the bottom here after setting up my enqueuers. Of course, I didn't have to maybe start them, but So I put this up here now. At least we can see, right, that well, I can't tell how many. I should put a number of messages that have been pulled out, right, and a number that have been posted. The way I'm computing these numbers is I just through function. The dialog box. Whoops. The dialog box has a sort of an increment-decrement pair. Right. Increment thread and decrement thread count. And I'm keeping track of the total and the number of deaths. So I don't need another number for births, because that's births minus deaths equals total. So I can do that here. This is thread safe because these numbers are they have a critical section associated with them, and the plus plus and minus minus operators actually lock and unlock that critical section. But since I'm doing both operations, I want to have it locked for the duration of this. That way, I won't get something out of sync. Plus, it might cost a little time if you lock, and then there's a task switch, right? Like, sorry, suppose you go through this increment, locks the critical section, turns the value on the stack, everything's fine. And by the way, when you declare one of these auto release things, I've proven this to myself, and return, the destructor is definitely called after this is placed on the stack. I wonder where I put that. Somewhere I wrote out the disassembly of that, and that was where, is that here? I have a thing called get unique WM app message or something. Oh, it's in WinBase. Is it gone? Here's some of the history. I took it away. I thought embarrassing or something. I don't know. What am I looking at? Project file. No, I want the file that I'm looking at. What? That's the project file, sure. But I don't have that selected. winbase.ts, winbase.oh, I know why. Project's not in here. Well, I can't add it to. Anyway, I had looked at the disassembly and proved to myself that those things are safe to do. A struct that has a destructor, when used in this sort of fashion. Okay, now I didn't change this one. It's more useful to return the value than to return what normally you would return a reference to an object for a pre-increment or pre-decrement operation. But in this case, what you want, and the thing that's perfect, it makes this a perfect operator, is that the value following the increment is just like interlock increment, right? It's copied onto the stack while during the mutual exclusion and returned on the stack, and then the thing is released, and it's not a reference or anything, it's a copy. Normally, these pre-increment decrement operators return a reference, right? Something that you can assign again. In fact, this could say, no, it's not const, but not in the case where there's multiple threads. You don't want any reference. You want a copy, and you want that copy on the stack, thread local. So therefore, with my dialog, therefore it's perfectly fine to pass these values to a function, and they can be used in the function however you like. But if in addition to that, if you already own the critical section, then the lock and unlock are just bumping the reference count up and down and doing nothing. And so these operations will be consistent. You know, the total will be correct. Similarly, for this one, I have a plus plus, and not doing anything with the deaths because there's no death here. There's a birth, but that birth is counted here. So let's see how we're doing now. Okay, we're up to 16. I believe it cannot go any higher. It won't get up to 2,000. And only 200 have died. At one point, what I had was and I may put it back, like a bulk DQ for the DQer to try and catch up with all the NQing. So that in one call it would get a whole bunch of answers back. I could put it back and see if it helped, but I found that it tended to stall. Because in the time that it's, see, I had this, I added another one that returned a whole list of these things, right? As many as it could get while the semaphore value was in the signaled state, right? So that every time you do succeed a wait, that reduces the value of the semaphore, and it's not going to go up while you're holding on to this mutex. I could show you, but I'm curious to see what happens. Then it turns into a kind of a race, and sometimes this guy just gets stuck for a long time, and this just kept piling on more. Oh my goodness, almost 17. It's 1936 or 1940 appears to be the maximum number of threads that a process is allowed to have going at one time. It's good now that I know that, but I'm curious. I haven't let it run long enough to get to the point where it's going to have to wait on 3,000 signals, right? Which will be reduced to 48 signals to wait on, each of which corresponding to one thread. So it's got to create 48 threads. I guess so. That's all right. These things will eventually die off, and once they die off, and once we have them all, it should work. But you'll notice that unlike every other program that you've ever run into in your life, this has 1,520 threads going, all of which are accessing this data, and this data, right? Well, no, only one thread is writing into here. But these two, the message queue, and it's not hung, it's not crashing, and it's probably not using that much processor. I doubt it. Shouldn't. Everything's in an efficient. Everything is doing its thing efficiently. WM Inc is the max. Yeah, okay, it's got 4%. So it can have Q 5, 2, because well, except for this new thing, which isn't going to kick in until we hit the 1900s. A request to start a thread should be succeeding at this point all the time. But when we get to the point where it's got to sit there and loop around until it gets a handle, then the processing time will probably go up. I'm not sure how best to tackle that. In terms of processing time, what you want is to sort of queue your request for creation of a thread, right? Following the next exiting of a thread, if that's possible. That would be the thing you'd want to do. All the operating system has is a list of these structures, right? The thread structure, and it goes from one to the next to the next. Switching the context, meaning the registers and the stack and so on. We're getting there. And then the hardware, it's hardware that interrupts the process. And then it just jumps to the next one in its list, right? So, oh goodness. Oh, it's going higher than. Oh, wait a minute, I'm looking at the wrong one. It's total active. This is just history. We're not close to it yet. No messages have been lost as far as I can tell. They're not in sync at all. Where's that J? I'm trying to find something recognizable. Puffy. There's some J's. Right, missed it. Look again. There's something I might recognize. One H all on its own. It's hard to see. I don't think it hit it. Yeah. There's quite a lot. each of these threads has an average of 50 messages that it will post before it dies. Alright, so 3,000 well, times 10 would be 30,000, and times 5, well, times 10 again, 150,000 messages on average to be enqueued and then dequeued. Oh, I just saw it, an H. There it is. I wonder if it's the same one. We need to find two things. CPM. A C all on its own and then a PM right underneath it. Very little chance of finding that by accident. Okay, we're getting close to the limit. You see that? They're both waiting. These threads are a lie, but I don't think any more are being, no more are being created, right? C, but no PM. The CPU fan is going a bit crazy now. I have to be careful of because it's not unlikely for my processor to overheat. But it's not from this, it's from the Windows Media Encoder. See? It's this thing that's causing all the trouble. I'll turn on my big fan. Sorry for the noise. It's either that or my computer dies. I'm gonna lose the video. Okay, 1934. This is the limit approximately. It may go as high as 1940. In normal speed, normal processing, this limit gets hit pretty quick, and it won't go any further beyond that. We've only seen 248 deaths out of 3,000. And it's not like they're being born, right? There's one. They're waiting to be born, right? It's stuck. This number is a constant. Okay, then we've got another one. And another one. That's how slow the creation of new threads is, because we've hit the limit. The hardware can't do anymore. Why? I don't know. Maybe there's compile setting or something to allow for more threads. Not like anyone would ever need all these threads. A thread is a very inexpensive way to get more bang for your buck, sort of. Of course, there's all the dangers of multi-threading, but if you can handle the danger, having multiple threads working on the same task really does speed up that task, the completion of that task. because you can do things in parallel, right? Make a real factory. So we're not getting any more threads. It's stuck now. It's hit the limit. So there you go. There's the limit, and I'm not going to do the whole video. This would have to get to 3,000, right? How long it's been? 30 minutes or something, and we're not even up to 300. So it would be several hours with this recorder running. I just thought I'd let you see that this can be done without any loss. At the limit of the capability of the machine in terms of threads, we have this marshaller, which is perfectly solid. Nothing, I don't believe anything is being lost, although the only way to be absolutely sure is to make a record of all, well, I have a record actually. All of these things are being put into a log file. This is Unicode, I think. Q, yeah. Now the sort by type. Most of these assert things are empty. The ones that just say log are like these traces. And the current one would be the one with the latest, the highest number, I guess. 827. It's up to 1.7 megs. When the program exits, in fact, for any of these things, if it successfully exits, the empty files get deleted. But as you can see, I haven't been gracefully exiting, stopping the debugger, not giving it a chance. One of the things that I learned in my quest to delete these empty files was this thing. See, the way to get those traces to come out of the file is to give to the CRT debug stuff a file handle, not a file name or anything, but a file handle. You say set file handle, or something like that. Where is it now? Okay, mode file, or close the log file. Where do I set the log file? Anyway, so I had these handles I was maintaining, but I wasn't maintaining the file name. CRT remove. That's memory. Now I'm just remembering the file name. But I learned what I wanted to find out was how to get a file name given a file handle. Okay, see, create file gives you a file handle, and the way to link it up with the runtime is to call one of these or both of these functions for the report file, just given a handle. And I didn't save the name, I just figured, well, can't be that hard to retrieve a file name from a file handle. I don't know if I can, maybe I put it in my favorites. They tell you how to do it. No. In the actual documentation, I wonder how you would search for it. It would be great if it said a search feature. Go to search. Search in progress. I haven't typed anything yet. Stop searching. Yeah, I want to type something else, please. File name, file handle. From file handle. And that should give you some code. Okay, oh, this is it right here. It's kind of comical, right? Because the thing is that what I want to check for is I want to delete the ones that are empty, right? So here's their function. They provide it free. Get file name from handle. Success is false. Max path, of course, is the maximum length of file name, as you know. Handle. Now this handle is something that's going to be created out of this, a file mapping. Now we get the file size. If the file size is 0, then cannot map a file with length 0 or return false. Right. But that's the only case that I'm interested in because I want to delete the empty ones, right? So in my version, I have that same, you can have that same comment. When should be in file utils. File name from file handle, maybe. It's in here somewhere. Maybe not this file. Okay, it's probably in WinBase. WinBase, which I can't add, can I? Not here. Let's see now. Maybe here. Oh, here's that comment. See, I'm checking to see if the release happens after the return. Anyway, environment variable clipboard to clip. Oh, come on. Where did I put it? Well, it's going to be in the comment H. Here. Here it is. Alright, now first thing is starts out with a local function that it's impossible to do in C++, but I need to have, well, I'd rather just define this function locally within this other function called getMappedFname, which takes a pointer to void of a mapped memory and loop forever. This function will return a number of bytes copied, not necessarily an error. But if get last error says insufficient buffer, then you have to keep adding more until you get enough buffer to fill up this, in this case, wide character string containing a file name given a region of mapped memory. For every region of mapped memory, there's a corresponding file, obviously, like an H instance sort of thing. So that's why I have that function. So now get the same as them, get the file size. Cannot map a zero-length file, true. So now I write a character to the file. One character. And it's important to do this flush buffers so that that character actually goes out to the disk. Now, of course, if I'm doing that, I want to remove that byte from the file after I'm done determining its file name, so that the person who retrieves this file name wants to determine if the file is empty, and so I got to get rid of it, right? So just inline here a very quick auto empty file, which will do its auto emptying provided this is true. See, the constructor takes handle to file to empty and a boolean whether or not to actually do it. That simplifies things. Now, I have a map file class, which I had to add this new constructor, which takes instead of a path name, a handle to file, and a number of bytes of that file that you wish to map. Hang on. Hello? Hello? Sorry about that. Right. So before that, I had to create a file handle and then map it. But this actually is easier. If you're given a handle file, then I don't have to do that step. I just have to call map view of file. That's a Win-based call, which takes a handle to file and a number of bytes to map. What could be easier? What does it return? Okay, well this function obviously fills in some stuff. Okay, I compute the size, high and low, combine that together into a 64-bit size. If size not equal to 0, oh, this is that thing from way a long time ago. Best to provide a proper security attributes for when you make file mappings, because file mapping is one of the portals of vulnerability to a process. There are file mappings. What else are there things? There are only like 4 or 5 different things that could open you up to vulnerability, or like pollution can get into your memory arena, and file mapping is one of them, because the default when you create a file mapping is that particular item, which is it is subject to the security rules. It has it has an associated DACL, a discretionary access control list, and all that stuff. And the default is pretty lax. Like anyone can read, so some can read and write. It's inheritable, things that you don't want when this is becoming part of the memory space of your process. It's best to keep this nice and locked off. But anyway, that's it. You simply call this create file mapping with a handle to file. This one's read only, but you can also do read write. And then in order to turn that into a memory, just like a regular old memory, we call this map view of file. It's like a window view of a file, which has a granularity of 1 page. So you can't really map, even though it's mapping 1 byte, I don't believe that 1 byte, maybe 1 byte's accessible, but the amount of memory that is mapped to a corresponding region on disk can't be smaller than at least one sector. No, it can't be smaller than 1 page, because the 32-bit memory model has as its the Win32-bit memory model has as its granularity is 1 page. 4 kilobytes of memory is the smallest, how do you say it? The smallest chunk of memory where I don't know how to say it in words. It all goes back to that stuff like in DOS it had segment and offset, right? The granularity is 10 hexadecimal bytes, right? That is a thing you can define a region of memory, but it has to be specified in terms of one of those segment numbers. Well, segment number granularity for Win32 is 4 kilobytes, not 16 bytes. That gives you the maximum amount of memory of 4 gigabytes that you can actually view anyway. Anyway, that's irrelevant. So going back to the famous function, I added 1 byte. Added 1 byte to the thing, right? So that I can not return false and actually get a name. And then I call my magic function getMapsFname here, which returns to me a file name from a pointer to mapped data. And now the only thing to do is to try and figure out which device that corresponds with out of the 26 possible letters, assuming it's a local on one of your hard drives or on a DVD or anything that can have a drive letter. The drive letters are really, although you can put hearts and diamonds and so on, the operating system only allows the letters from A to Z, and so you just start out at A and call this query DOS device. What that gives you is, did I finally put an example of one? It's something like device / disk 0. I don't have an example. Maybe I can stop this program. You see how long it's taking? Just forget it. Oops. No, let's see. How about here? What am I doing here? It's all in assembler, but I don't need it now. See, I was starting to think about semaphores and how to plot all that stuff. What I want is to take a file handle and turn it into a file name. So, create file, file name, something that exists. I love this trick that shift right click, copy as path. All you gotta do, put in some slashes. Zerd access. Oh, I don't know what to get. Read, just read. Okay, all. What's the easiest? All access. All possible. Share, none. Oh, that's what I want. Generic, read. And examples. Don't want that. Don't want that. That's for doing a backup. Hold on. Share mode, none, just 0. Security attributes, 0. Creation disposition. I don't want to create, alright? Creation disposition is the thing that determines whether or not the file should be created. Where is it? Here. Whether or not you should create it or fail if it doesn't exist and so on. Open existing. So this would fail if it doesn't exist, I hope. Well, I don't care about that file. Flags and attributes. No. Template, no. Okay. file. What is it? It's just -1. And now I have a handle to file, and I'm going to turn this. Oh, is that enough? Generic read? Oh no, I need read and write. Generic. I don't want execute. Just read and write. Because I need to write 1 byte in case the file is empty. Alright. Here's the magic. File handle to file name. Why wouldn't I have called it OTS? There's a link. I wonder if I'll upload this video. It's just me rambling, really. Okay. First part succeed. It did succeed. Handle is 80. The size is low and high is 0. It's not empty, so we don't need to write a file, but I still need to declare this thing, instead of doing it by cases. Now I want to create a file mapping for that file. Invalid handle. Okay. Map view of file, it's not my function. Success was true. So that means that there's a success, and now the magic. This is the magic, my inline function. Okay. Well, this is just chunk size is just it's a thing to do with this macro, whether or not to use the stack or the heap. Get mapped file name W takes a current process ID, a pointer to mapped memory, a buffer, and the size of that buffer. Now it's copied 43 bytes. Last error is 0, so it succeeded. That's true, and then I just return this string. So that's those funny strings. Now you can't just say that because this is a 3, therefore it has to be 0, 1, 2, 3, 4, A, B, C, D. In fact, it works in this case, but you can't rely on it. You have to go through this step. Just start out with each possible drive specifier, which is a letter followed by a colon, and then call this query DOS device. Again, another one of these things where you grow the string, but the OS call has exactly the same name. And like all these other ones, it tells you how many bytes were copied. 0 in this case. And the error code was 2. So if equals 0, that's true. Return invalid delay. Oh no. Yeah. I'm going to return invalid delay. Why is that? Oh, it is invalid. That's true. Because I don't have an A drive. Okay, so I got invalid device, and that's certainly not it. Next, B, we'll give invalid again. C, though, should work. Copy. That gives me device hard disk volume 2. If copied less than size, that's true. And code is success, it is. Return the string. That string, now I'm doing just the comparison. Is this string head equals to this string? Right? Stir ret, the big long one, is the head of stir ret equal, without regards to case, to what I got from this? And the answer is no. So keep going. Do that with D. Now they are head equals. So now I cut off the length of this thing that I retrieved. That leaves me with this, and add to that the device specifier I used, and that gives me a path name with the device specifier. And there you go, a handle to a file converted into a actual file name. And it works even if the file is empty. Alright, that's enough for me. Hope you had fun. See you.